Hello there and welcome to this video, which is looking at writing and balancing chemical equations. There are a couple of rules you need to know, the first of which being that a lot of the gases are often diatomic. Now these are the ones you need to know. So we've got oxygen, hydrogen, chlorine, fluorine, iodine, bromine and nitrogen. The second rule is that if I put a number in front, I double everything. So if we look at the example here of water, which is H2O, if I were to draw out a H2O molecule, it would look like this. It's two hydrogen atoms attached to one oxygen. So if I'm doubling it, what I'm effectively saying is I've got two lots of that water molecule. So I have 2 times 2, which is 4 hydrogens, and 2 times 1, which is 2 oxygens. Rule number 3 is have a look at whether it's all capitals or a capital and a small letter. If you have two capitals, like here, I have carbon and oxygen. However, if you have a capital and a small letter, that means you have cobalt. So it's really important when you're writing it and when you're reading it that you make sure you know what's what. The fourth rule is that if you have a small subscript number, it only applies to the element before it. So in this case of magnesium chloride, I've only got one magnesium, but I've got 2 chlorines. So that little 2 only applies to the chlorine before it. However, if there are brackets, then everything inside that bracket is multiplied by the number outside of it. So here I've got MgOH2, which means I have 1 magnesium, but I have 2 oxygens and I have 2 hydrogens. Same applies down with my ammonium oxide down at the bottom. I've got 1 oxygen. However, inside my brackets I have 1 nitrogen and 4 hydrogens, but I've doubled it. So that 4 is doubled to give me 8 hydrogens in total. And then nitrogen, as I said, I've got 1 inside, but I've doubled it because I've got 2 outside the brackets, therefore I've got 2 in total. Now the reason for that is because when I have Mg and then OH in brackets with a 2, it's showing me that I've got 2 lots of OH compound ions attached to that magnesium. So I've got an OH here, which is 1 oxygen and 1 hydrogen, and then I've got 2 lots of it. So as you can see here, I've got 2 oxygens and 2 hydrogens because I've doubled everything inside that bracket. And the final rule is, in a lot of these ones, you're going to need to actually find the formula to be able to work out the formula of the compounds. Now if you're not sure how to do that, have a look at the video with the list of ions on the left, and also look at the finding the formula video on the right. It's important to watch both of these videos first before you continue with the rest of this video. Right, so let's put these rules into practice then. So here we have Mg plus H2O goes to MgOH2 plus H2. So let's have a look. Start out by counting the number of atoms on either side. So we've got magnesium, hydrogen and oxygen both on the left and the right. I've got 1 magnesium, I've got 2 hydrogens, and I've got 1 oxygen on the left hand side. On the right I've got 1 magnesium, and as I showed you earlier I've got 2 oxygens, and then I've got 2 hydrogens inside the brackets, but I've also got another 2 from my hydrogen gas. So I've got 4 in total. So the next thing you need to do is figure out how to balance it. I've got 2 hydrogens, I need 4, I've got 1 oxygen, I need 2. So in this case it's simply a case of finding the one that's got both those in and doubling it. If I double the H2O, I get 4 hydrogens, I've doubled my number of oxygen, so I get 2, so therefore it is balanced. If we have a look at another example, so this is a neutralization one, where I've got magnesium hydroxide reacting with hydrochloric acid to make magnesium chloride and water. So I look at all my elements and write them down. So I've got magnesium, oxygen, hydrogen and chlorine here. I count up on the left and the right hand side again. So I've got 1 magnesium. As I showed you before, I've got 2 oxygens. I've got 1 hydrogen in the bracket multiplied by 2, and then I've got 1 in my HCl. So I've got 3 in total. Chlorine, I've just got the 1. And then on the right hand side again I've got 1 magnesium. I've got 2 chlorines. I've got 2 hydrogens. And I've got 1 oxygen. So the only thing balanced at the moment is my magnesium, the oxygen, hydrogen and chlorine or not. Now, My best suggestion to you is to look for something that's unbalanced. We've got hydrogen and chlorine, so I'm going to choose those. Double it, let's see. So I've got 2 chlorines on the left and 3 hydrogens. So if we double that, I get 2 times 1 is 2 hydrogens added to my 2 from magnesium hydroxide gives me 4, and I get 2 chlorines. So my chlorines are now balanced. But my hydrogen and my oxygen aren't again, and as you can see I need to double both the oxygen and the hydrogen. I've got water, so I can put a 2 in front of that. So if I do that, I get 2 oxygens, and then I had 2 hydrogens, I times that by 2, and that gives me 4, which is also balanced. Okay, one more example then. So this is Fe2O3 plus C goes to Fe plus CO2. So this is an example of a reduction reaction. So I've got 3 elements here, iron, oxygen and carbon. So we do the same again, we count up on the left and the right. So in this case I've got 2 irons, I've got 3 oxygens, and I've got 1 carbon on the left. And on the right I've got 1 iron, I've got 1 carbon, and I've got 2 oxygens. Now, as I've said in the simple balancing one, is if you've got a big compound that is uneven, then double it. So in this case, that's my oxygen O3. So if I put a big 2 in front of that and recount, that gives me 2 times 2, which is 4 ions, 2 times 3, which is 6 oxygens, and that's it. So I can now go over to the right hand side and see what I need to do. So what do I need to times by 1 to give me 4 ions? The answer is 4, so I can put a big 4 there, and that's balanced. Oxygens, I need 6, and I've got 2. So 2 times what gives me 6, so the answer to that is 3. So put a big 3 in there. And then finally I need to recount my carbons because I've multiplied that by 3, so I've got 3 of those. Therefore on the left hand side I've only got 1. What do I times 1 by to get 3? And the answer is 3, which is now balanced. On to the next one then. So this one is a combustion reaction. So we've got C2H5OH plus O2 gives me CO2 plus H2O. So I've only got carbon, hydrogen and oxygen here. So let's count up again. So I've got 2 carbons on the left. Hydrogens I've got 5 plus my 1 at the end there, so that's 6. And then oxygens I've got 1 in my C2H5OH and then 2 in my oxygen, so that gives me 3. On the right hand side I've got 1 carbon, 2 oxygens in my carbon dioxide, plus 1 in my water, so I've got 3 of those, and then I've got 2 hydrogens. So once again we've got a big compound here with an odd number in, which is my C2H5OH. So the first thing I'm going to do is double that. So that doubles my carbon and gives me 4. It doubles my hydrogen, so it gives me 10 plus 2, which gives me 12 overall. And it also doubles my oxygen, so I've got 2 inside that compound. Plus my 2 from my oxygen gives me 4 in total. So, what do I times 2 by to give me my 12 to get hydrogen? The answer for that is 6. So if I put a 6 in front of my H2O, that balances my hydrogen. I can then look at my carbon. I've got 4 on the left. What do I need to times that by? So I've got 1 times by 4 gives me 4, so I can put a 4 in front of my CO2. Of course, by doing both of these, I've changed my oxygen as well. So I have 4 times by my original 2 in my carbon dioxide, which gives me 8. And I had 1 oxygen in my water. I've times that by 6. So therefore, 8 plus 6 gives me 14 in total. My carbon and my hydrogen are balanced, but my oxygen I've got to sort out. Now this gets a little bit more complicated because I've got 2 oxygens from my C2H5OH. So of those 14, 2 of them I don't need to touch because I've already doubled that, so I can take that away. So if I take that 2 away from my 14 that I need to get, that only leaves me with 12. Therefore, what do I need to times by 2 to get 12? The answer is 6. So if I put that up there next to my O2, that makes it balanced. and gives me 14 in total. Now that might look balanced, however, we can simplify this further. All the numbers in front of our elements and compounds can be divided, and they can be divided by 2. So if I do that, 6 divided by 2 gives me 3, 4 divided by 2 gives me 2, 6 divided by 2 gives me 3, and 2 divided by 2 gives me 1, which I don't actually have to write down. Now if you do something like that, it's always important to check it, so let's have a look. So I have 2 carbons, I have 5 hydrogens plus 1, which gives me 6, and then oxygens I have 1, and then I've got 3 times 2 is 6, which gives me 7 in total. So 1 plus 6 equals 7. Then on the right hand side I have 2 carbons, I have 2 oxygens times by 2, which gives me 4, plus my 3 from my water, so 3 times 1, so that gives me 4 plus 3 is 7, so that's balanced. And then hydrogen, 3 times by 2 gives me 6, which is also balanced. Good point there, always check afterwards. Okay, that brings us to the end of this part of the video. However, it doesn't stop there with balancing equations. What I've done is I've prepared 6 extra videos which go into detail on the 6 areas where you need to be able to balance the chemical reactions and also write them if you're going for the top marks. So, the ones you need to be able to do are reactions of metals and oxygen, reactions of metals and water, displacement reactions, complete combustion, neutralization reactions, and reduction reactions. So, click on any one of these videos now and have a go and see how well you do. Hi guys, I hope you enjoyed the video. If you did, click on the subscribe button down below, visit the website, and you can find me on Facebook and Twitter.